So hello everyone. I hope you all are having a great day and enjoying this session so far. Today I'll take you on a journey from monolith Terraform setup to a modular, scalable, and well-governed infrastructure. So whether you're managing a single cloud account or multi-account setup, I'll explain how to simplify complexity and scale Terraform confidently. So before we dive into the session, let me take a moment to introduce myself. I'm Kanika Maurya. I currently work as a cloud platform engineer at JP Morgan, and I have 6 years of experience. And my work revolves around Terraform, AWS Cloud, Azure, Kubernetes, pipelines, and all. And outside of my professional role, I'm an active tech speaker and absolutely love contributing to the community. So whether it's through meetup, conference like this one, or mentoring aspiring engineers. So I'm passionate about creating space where people can share, learn, and grow together in tech. So with that, let me walk you through what we'll be covering today. Let's take a quick look at what we'll be explaining. So we'll start by understanding Terraform, then we'll move on to the monolithic Terraform setup. The way many teams start out, right? And it worked initially, but as your infrastructure grow, it starts showing cracks, which led us to the challenges. So that come with the monolithic setup. And after that, we'll see how to overcome those limitations through modularization and explore the different ways to use the Terraform modules. Then we'll see workspaces and how they can make multi-environment management simple and scalable. And toward the end, we'll touch on the Sentinel and understand how it helped to enforce governance and compliance. And then finally, we'll wrap up with the key takeaway. So let's kick off the session. Okay, so let's start with the foundation, which is Terraform itself. Terraform, as many of you might already know, it's an open source infrastructure as code tool developed by HashiCorp. It is designed to automate infrastructure provisioning, whether you are, using cloud, be it AWS, Azure, GCP, or even on-prem environment. So the key idea behind Terraform is that you have to define and manage your infrastructure declarative through code. That means instead of manually creating the server, database, or network from the console, you can simply describe what you want in configuration file, and your Terraform takes care of that. And the beauty of this approach is that this is cloud agnostic. So you can manage resource across different cloud providers and using the simple language and workflow. So whether you're deploying to AWS, Azure, your Terraform code basically, the structure, whatever you will follow, and the workflow remain consistent. And Terraform uses HCL language, which is HashiCorp configuration language, which is clean and simple and human readable. So it is designed to make your infrastructure easy to understand and maintain even for large and complex environments. Then, if you remember in this slide, just a minute. Okay. I want to take a moment to explain what is happening here in the image which I have added. So here you can see there is a Terraform project, okay, which contains the Terraform configuration file and state file. So we'll talk about the state file in later slide, but let me keep my focus on configurations. So this is where you are defining your configuration or infrastructure, whatever you want. And once you are done with that, what you can do, you can use the commands which Terraform offers to plan or validate your changes or whatever you're trying to create. So using the Terraform plan command, you can simply, go to this Terraform plan, you can hit that, and then it will show you whatever you have written in your configuration file. So, and what it will create or destroy. And once you are satisfied with the plan, you can do the apply. So whatever target or destinations you have added in your provider, it will try to create those resources into the respective destination. Let's talk more about the configuration file. So what happened here, okay, so here in the configuration file, every file inside the folder, which you can see here, okay, has a specific purpose. And whatever you define with .tf, right, it will take that into consideration and it will start using that to create your infrastructure. So let me quickly go through the each file and tell you what it does. So basically main.tf, what I'm trying to do here is, this is your core file, okay? And this is where you define your actual infrastructure, be it VPC, EC2 or S3 bucket, or whatever resources you want to take up. Then variables.tf, this file actually declare your input variable and it makes your configuration flexible and reuse. And provider.tf, this is where you will add your providers, whether AWS, Azure, or GCP, or anything other than that if you want to use. And version.tf, this help you to define your Terraform and provider versions, okay, so that it ensure that you have the consistent versions across environments. Moving on, Terraform state file. So this Terraform state file actually, it help you to keep the track of what already built and what you will try to build. So that will be captured inside this Terraform state file. So Terraform uses this file called terraform.tf state to maintain a detailed record of your deployment infrastructures. So you can think of this file as a Terraform memory, or it is a single source of truth. It know exactly what exists in your environment and how it maps to your code, whatever you have written. For example, you have created an EC2 instance or an S3 bucket. So the state file stores its resource ID, dependency, metadata, or even the relationship between those resources. So this is what allow Terraform to know the difference between what is already provisioned and what needs to change when you run another Terraform apply. And by default, Terraform stores this file locally in your working directory, typically as terraform.tf state. But as your project grow and you want to keep that into a remote backend, you can even do that. Let's take an example, okay? Let's create this session a bit more realistic, okay? Suppose you are a cloud engineer and you have just a requirement to create few essential resources, okay? As shown in the image, suppose you got a requirement to create S3 bucket, security group, VPC, EC2 instance. So at first, this seems like a simple and straightforward task, right? So you open your code editor and start writing your Terraform configuration to define all these resources together in a single file. Now you'll think, all right, let me just write everything in a single place and it will be easier to manage and quick to deploy, right? But honestly, this is how most of the Terraform journey began. Almost everyone starts this way. A single configuration file that handle the entire setup. It worked beautifully in the beginning, especially when the infra is small and team is just of one or more or 2%, right? But over the time, as more resources, environment, and developers get added, this approach start to show cracks, right? So let's take a look at what single configuration file or the monolithic setup looks like. So here I have attached a snapshot of code which I was trying to create and show it to all of you how the monolithic Terraform setup looks like. So suppose the engineer which we have seen into the earlier slide, she open her editor and start writing everything in a single Terraform configuration file. So as you can see here, she has started writing all the resources, the VPC, subnet, security group, and let me show you slide as well. Here, also adding the compute instances and the S3 bucket resources. So what's the problem here? So in early stage, this approach feels convenient. There are just one state file, one directory, and one person managing it. But you don't have to worry about the complex model structure or dependency. But here the stories start to change. Challenges. So let's see what are the challenges this monolithic Terraform setup throws to us. The first issue is that everything lives inside one massive code base. There's no clear separation between resources, networking, compute, storage. Everything is tightly coupled. It becomes very hard to manage or troubleshoot, right? Because a small change in one place can unexpectedly affect another. Next, we have slow plan and apply time. Since Terraform has to evaluate every single resources in that huge configuration, right? So even a minor change, like suppose updating a tag, triggers a full Terraform plan across the entire infrastructure. So things get even trickier when you introduce multiple environments like dev, test, and prod. So instead of having a separate isolated state, all of them often share same configuration and same state file. And when even more engineers join in, you start seeing team conflict. Over time, all of this make the setup hard to scale, hard to maintain, and extremely risky to modify. So even though the monolithic approach was fine for an engineer in a small setup, it does not hold up when you need collaboration, right? So this is all the challenges we see. So what comes as a savior for us? Modularization. Modularization simply means breaking the large and single Terraform configurations into small, reusable components, what we call modules. Each module is like a building block that represent one logical piece of infrastructure. For example, you might have one module of your VPC, another for EC2 instance, and one for S3, okay, and maybe another for IAM role. So instead of repeating the same code across multiple environment or project, you define a module once and then reuse everywhere, okay, whenever you need, just by calling it. So think of a module as a mini blueprint. Each one encapsulates its own logic with clear defined input like region or instant type or CIDR block, and outputs like subnet ID, IP addresses, or bucket name. So this approach make your infrastructure not only consistent and scalable, but also version control. You can also lock versions of module to ensure everyone is deploying the same tested configurations. So that's how modularization brings the structure and maintainability to your Terraform code. Okay, moving on to the next slide. So as we discussed what is modularization and how it comes as a saviors from the monolithic setup, we'll see ways to use the Terraform module. Currently, in this slide, I'm starting with the local module. Local modules are modules that are stored inside your Terraform configuration project itself. So they are perfect when you just start to modularize your infrastructure or when you want to keep everything self-contained. So in this snapshot of code where I've attached, you can see I am creating local modules named as compute, network, or storage. And in the root main.tf, I'm simply calling those modules, right? So typically, you can create a folder called modules and you can name it as per your logical component. Like I have named it here network for VPCs and compute for EC2 and S3. For S3, I have named it as storage. Now, each of these subfolder behave like its own small Terraform project. It has its own main.tf, variable.tf, and output.tf. Let me show it to you, the breakdown of each module component I've created. So you can see here I have the main.tf and output and variable.tf of each modules. Okay, so we have the storage module which defines the S3 bucket, if you can see it here, and we have the network which create VPCs and subnet, and inside the compute module I am trying to create an EC2 instance with the security group. So this modular layout is much more scalable than the earlier monolithic setup, where you can add, update, or reuse any component without affecting the rest of the infrastructure. Let me talk about the remote modules. So these remote modules are stored outside of your local project. As we have seen in the local module, your modules are inside the current project where you are calling it. But in the remote module, they are stored outside of your project, usually in shared locations like GitHub, Bitbucket, or even S3 bucket. Okay. So what you can do, you can you can simply pull those Terraform configuration using the source parameter. As you can see here in the snapshot I have attached, I'm simply using the source tag, source argument here and passing it the value of GitHub location. So it will simply fetch the configurations file from there. And this ref equal to version, which I have mentioned here, this part lock it to a specific version tag, which ensures that everyone using this module get the exact same tested version. The big advantage of remote module is cross-team collaborations and code standardizations. So with remote module, your team can publish pre-approved module. For example, a standard VPC or EC2 setup. For example, you need standard and the standard coded VPC setup. So instead of everyone going and writing on their own, you can create a configuration make it in a form of remote module, and publish it to the GitHub repo. And other teams can simply reference them in their own project. So this not only saves time, but also ensure every team is following the same security and architecture standard without having to reinvent the wheel. Moving on, public registry module. So after local and remote module, let's take it one step further. Okay. So Terraform has a fantastic platform called public module registry. And the link is registry.terraform.io. So that hosts thousands of pre-built and community-vetted modules created by HashiCorp, cloud provider, and even the open source community. So these modules are designed to handle common infrastructure patterns, things like VPC, S3 bucket, RDS database. So you don't have to reinvent the wheel every time you start a new project. Here it shows a VPC module, okay, being used directly from the public registry. With just these few lines of code, you are pulling a fully functional best practice AWS VPC module, complete with subnet, routing tables, and net gateways, all maintained by the Terraform community. So what's great about public module is that they are battle tested, widely used, documented, and updated regularly. They save developer time, especially for standard setups like networking, IAM roles, or load balancing. Moving on to the next slide, private registry module. So a private registry module is essentially a centralized and organized organization-wide module repository, typically hosted in Terraform Cloud or Terraform Enterprise. So here teams can publish and versions and approve module internally, just like a public repository, but with full visibility and access control within an organization. This module enables reusability, governance, and scalability. You are not just managing infrastructure anymore. You are managing a reusable infrastructure product now. So in this example, this EKS model is not pulled from the public Terraform registry. It is coming from the private internal registry, scope to your organization. So the real power here is governance and consistency. Every module in the private registry is reviewed, approved, and version controlled before it become, available for others to use. And this setup is not only standardized infrastructure, but also improve security, compliance, and operational efficiency. So in short, private registry bring order and trust to your Terraform at scale, allowing team to move fast without breaking the governance rule. With that, let's see the benefits of Terraform modularization code. So as we have explored all the ways to consume the module, like local, remote, public, and private, let's see the benefit. So modular Terraform is like turning a cluttered toolbox into a neatly labeled compartment. Everything is organized and easy to find, right? For example, instead of writing the same VPC or EC2 code again and again for dev, test, and prod, you just build a module once and reuse it everywhere. Each module keep its own state. So if someone update the S3 bucket module, it won't break your EC2 setup. Just an example. Everyone works safely in parallel. And you can also have versions in your module. Say you are using 1.0 for productions and while testing your version 1.1 in staging, just like app releases, right? And this make updates safer, fix faster, and collaboration is smoother. Even every environment like dev, test, and prod follows the same blueprint, and you can customize it in form of using variables and other techniques. And in short, module turn a Terraform infrastructure from chaos to something predictable, reusable, and scalable. Let's see another core and important component of Terraform, which is workspaces. So Terraform Workspace provide a clear and efficient way to manage multiple environment, which we were also talking inside the modularization, right? Such as a dev, staging, or prod, and using the same configuration. So instead of duplicating your .tf file, why I'm saying .tf? Because whatever you write and ending with .tf file, Terraform consider that as a configuration language or whatever you want to create and deploy it into the respective cloud. So instead of duplicating .tf file for each environment, we can create isolated state file through workspaces, because each workspaces track its own state file independently, which means changes applied in one environment does not change or interfere with other. And the command here I have shown that illustrate that you can use Terraform Works new and then your workspace name. For example, I'm using dev. So it will create different workspaces for dev, and whatever you will try to provision through these workspaces, it will create a different state file which will be different from the prod workspaces which I'm creating in second command line. And if you want to list what all workspaces you have, you can make use of Terraform Workspaces list, which help you to view all the available workspaces. And the if you want to select and by default you will be in a default workspace. And if you want to select a particular workspaces, you can make use of this command Terraform Workspace select and your workspace name. So this is how you can switch between the workspace and even create a new workspace. And in the second image, what I'm trying to show here is, suppose you have the configuration file, right? So you can see the directory structure here. Terraform automatically store the state file under terraform.tfstate.d folder, okay, with a separate folder for each workspace. So this approach allowed team to maintain environment of isolations while still, managing everything from a single code base. Here comes the benefit of workspace. So as we have seen how powerful the workspace can be, right? And especially to isolate your state files, which is very essential when multiple teams start working together. So Terraform Workspaces simplify multi-environment management by isolating the files. And as each workspace has its own state file, so there is no interference between the or state file corruption issue. And using one code base across environment, you can reduce the duplications and eliminate the drift. And this isolation lead to a safer deployment also. Means if you have suppose a failed dev changes, right? So it will not impact your production because on and all state file is isolated. And it also guarantee consistency. How? Since all environment follow the same modular structure and version code, right? So this will allow that you have the same consistent code across every environment. And finally, workspace make scaling easy. So you can replicate the infrastructure across multiple regions or account with minimal effort. Now, as we have covered structure and scalability, let's talk about compliance. And here comes Sentinel. So Sentinel is a policy as code framework that integrate governance and compliance directly into your Terraform code and Terraform Enterprise. It allows organization to enforce rule and policy as code, ensuring that every Terraform change follows security and compliance standard before it deployed. So Sentinel work as a preventative control. But before moving into what it is, I'll show you or I'll talk about the two type of control which we have, detective and preventative. So detective means it will identify the violation after something is deployed. Okay. So but preventative control is done through Sentinel only. So how it is different from detective? It means it evaluate your Terraform plan or any changes before deployment and stop the non-compliant changes from being applied. And it also provide the fine-grained policy enforcement, like it will allow you to have the different enforcement level, which allow, deny, or warn based on the Terraform output you have. For example, it can enforce tagging standard, restricting instance type, or block your deployment to unapproved region. So this all can happen automatically once you start writing the Sentinel policies and apply it to your Terraform configuration file. Moving on, so Sentinel policy, how it evaluate your code, right? So as we know that whenever we write any configurations, we start with Terraform plan to see what it is creating. And once we are okay and good with it, we can simply go ahead and do the Terraform apply. And it will start creating your resources actually into the cloud. But if you want the Sentinel policy, and suppose we have created the Sentinel policy, so where it will be placed? So it placed between the plan and apply phase. It help you to evaluate the changes before actually applying it. So once your Terraform plan runs, Sentinel automatically kicks in and evaluate the plan output against the defined policy. You can create your policies according to your organization need or any requirement. and it checks if the proposed infrastructure changes follows your organization rule. And the same example I can say, like enforcing tag or approving a particular instant type. And if everything is compliant, right, Sentinel allow the apply phase to proceed. If not, it will block the deployment before any resource are created. So Sentinel evaluations act as a policy firewall, we can see, right, verifying compliance before anything is applied. Moving on, Sentinel has three flavors of enforcement level, okay? Advisory, soft mandate, and hard mandatory. Sentinel giving us the flexibility to restrict the policy, restrict the changes, and enforce the policy. It not only block or allow. Instead, what it does, I'll tell you. It provides three enforcement level as it is shown in the slide, right? So, as its name suggests, advisory. This level is not blocking. Sentinel simply check the policy and give you a warning. So, if something fails, right? So Terraform will allow you to apply the changes, but it will give you the warning. So that's how the advisory work. So if let's take an example, if you are the initial level of enforcing the policy and you don't want to disturb the customer or your team, you can have the policy for the first phase, which is advisory, so that people start getting it as a warning that okay, this is not the correct or not the compliant way of writing the configurations according to the policy you have created. And once you are okay, like okay, everyone knows this and they are trying to move to the better and compliance code, you can make it slowly to soft and then hard mandate. And talking about a soft mandate, as its name suggests, it enforces the rule, and if policy fail, it will block the apply. But authorized users can override it manually after review. So this is perfect for staging, or I would say test environment where you want to enforce the standard, but still have the flexibility in exceptional cases. And the third one is hard mandatory. This is a full governed module. So if policy fail, you are done, bro. The apply will not happen. Okay. Key takeaways. As we come to the end of this session, let's take a quick moment to recap the journey we have covered today and lesson learned. So we started with the idea of IAC, where automation and consistency replace the manual provisioning, enabling fast and more reliable cloud development. Then we looked on how monolithic Terraform setup, while a simple at start, can become difficult to scale and govern as infrastructure grow. And that's where modularization come in and breaking large and complex setup into reusable and maintainable and version controlled way. Then we also explore Terraform Workspaces, simply simplify multi-environment management and allowing dev, test, and prod to share the same code base while keeping their state file isolated. And then finally, we saw the Sentinel bringing policy as code, enforcing governance and compliance before any resources is deployed. So in short, moving from monolithic to modular Terraform is not just a code that change, right? It is a mindset shift. It transforms your setup from chaos to a better, scalable, and reusable infra. And that's bring us to the end of the session. Thank you so much for being such an amazing audience. I hope this session helped you take the next step toward building scalable, secure, and well-governed Terraform workflow. But before we wrap up, I would love to stay connected with all of you. You can scan this QR to reach me on LinkedIn. And the best part about community talk like this is the conversation that continues after the session.